So I've been thinking about Jay's project here for the last couple of days. And if you remember my previous videos that he would like to have a RGB or a green LED, or pretty much basically what he wants now is an LED that needs a 3-volt power supply to run it. So I've tested these two items here, and they got a red LED, which means that, you know, that supply voltage could be anywhere from 2 volts or less. So when I tested these, they tested out about 1.7 volts, and that's loaded circuit. Not to say that, you know, I snipped the LED that the voltage may change, but I'm assuming there's not much voltage there to begin with, you know, other than no more than 2 volts. So what I've got here, you know, like his digital answering machine here, he wants pretty much wants an LED right here that kind of sticks up, and maybe even at an angle or something like that, where he like to have a green LED. So green LEDs are, especially today's green LEDs, are bright and vivid. You can't miss it. And on top of that, since it's green, the human eye really picks up on green. Doesn't matter, you know, what the intensity is. Our human eye is just attracted to green. It's very sensitive to it. And on his caller ID boxes here, they got a little puny little LED in here that tells you that there's a new call message on there and stuff like that. And he says, you know, instead of the red, that he'd like to have maybe a flashing RGB. And of course, the flashing RGBs, they run automatically. There's a little chip in there that changes the colors, but the primary voltage of that is 3 volts, and it's not going to run. I don't think they run very well past 2.8 with any 3-volt LED. They may light, but a steady LED may light very dimly, but an RGB, once it tries to switch over, it's going to reset the chip. So it's basically going to stay on red all the time. So I've been thinking, well, what can I do to drive a 3-volt LED off of 1.7, you might as well say. So in my arsenal, I got these little boost converters, and when I bought them, they give you specifications of what they're supposed to do. So since these are boost converters, and I got 2 different sizes, they're pretty much the same thing. There's just a little different package. They claim 2 volts is the very minimum that they'll boost at, but you just don't know unless you test it. So that's what we're going to do here on this particular video, is we're going to test to see what they will boost at, because I don't really know, because I've never tested it. So we're going to test this, and I'll bring you in a little closer here. We've got the big Clive view here going. So I'm going to use a little power supply here. This is actually a little buck converter. So we're going to have a little buck converter. I'm going to set the voltage at, so whatever the voltage is on it right now. So it's got 3 volts. So basically on a boost converter, theoretically, whatever voltage you're at, it's supposed to boost it. So obviously we know that these are within a range of a certain kind of voltage, so we definitely know that 3 volts, it's going to go 4 volts and to whatever the thing is rated at. But I want to know how long or how low the voltage you can get that it will still boost at. So we're going to hook one of these up to a little supply here, and we'll collect the voltages correctly here. And of course, we all know that it's going to be boosting at 3 volts. So let me drop this down to at least, let's try starting at about 2.5 volts. Actually, we'll start at the bare minimum, and we'll say 2 volts. So we'll bring this to 2 volts. Something like that. So we got a starting point. So now on the other end of this thing, we should have, you know, whatever this thing is boosting at. So we'll see what the voltage is.
Already on auto mode. DC voltage.
So we'll connect our little pen voltmeter here, and we'll see what we got for a voltage. So we got about 2.5 volts, which is, you know, probably
2.543
bare minimum for an LED. So since this is a booster,
2.545 volt. DC 2.546 volt.
so we'll bring it up to about 3 volts.
DC 2.323 volt.
So we'll say 3 volts. That's our target voltage that we want to run a LED at. Well, since this is a boost converter, we want to know how low we can go on the supply voltage to see what we can drive this at. That's the purpose of this. So right now we're at 2 volts and we're driving at 3 volts. So for this little boost converter, that's an easy task. So since I don't have 100 hands here, we have to do a little work here to keep this going. So we'll hook our little test club here. So we're at 3 volts. And now we're going to start jacking down on the voltage here to see how low we can go. So we're going to start dialing back the voltage. So we're at 1.9. And we're already at line voltage. So we stopped boosting at 1.9 volts.
1.744 volt.
So that's a far cry from 1.7, which is our tested voltage. So we'll see how much it comes back up till it starts boosting again. So it's got to be a little bit over 1.9 volts. So we'll say that, 1.7 volts is, if that's my true voltage, the boost converter is not going to work for this particular setup. So you need over 1.9, and we'll say that all I got is 1.7. So we'll put that voltage back up, and just for giggles, we will try this other board here, which is probably going to be about the same results. But you never really know unless you test it. So with these little guys, you got to pay attention to which is input and output. So this is the input side. So we got 2.4, we're boosting at the 2.6. So for this little guy, we'll jack this up. So we get the 3 volts. So there's our 3 volts.
3.025 volt.
And we'll start jacking this down to whatever it's going to cut off at. So there's our 2 volts. Even at that, even 1.9 it shut down. So you need over 1.95 volts to for this particular little board to boost that. So to try to put these in, it's not going to work. So that's a bummer. So I've looked into other little little buggers like charge pumps and stuff like that, voltage pumps and stuff like that. There's just nothing available, or it's too complex. Like with the voltage pumps, a lot of them use a microcontroller to run it, and then you got to have a supply voltage to even run the microcontroller and stuff like that. So sort of a waste. But there is one other thing that I can try, and it's your classic Joule Thief. So we're going to try a little Joule Thief here. So here's the schematic of a Joule Thief. And with most Joule Thieves, they need like a hand wound transformer. Well, most hand wound transformers are kind of big and chunky. So when you're trying to cram it into something that's really not designed to have anything else built into it, there's not a lot of room to stick stuff in these things. Unless the bigger the device is, the more room that is available. So I looked around on the internet for Joule Thief circuits, and ironically there is a transformerless Joule Thief. And what it uses to replace the hand wound transformer is a 100 microhelix inductor. So in place of the transformer, we're going to be using an inductor. And then the schematic here, like this is our input voltage here. So this can be anywhere from 1.5 volts or less. And then we got our positive rail here, and it goes all the way through our little LED. And then we got our negative rail here that goes to our LED. Then we got stuff in the middle that makes this whole wackiness work. So first thing is a 330 ohm resistor, and this goes to one of our transistors, which is a BC547 transistor. And then so the resistor goes to the pin 1 of the resistor, and then pin 3 goes to ground. Meanwhile, our pin 2 comes up here and connects to 2 more components, which is also connected to our positive rail, which is a capacitor, a 220 picofarad capacitor, and a 22,000 ohm resistor. So 2 of them are together. They go into pin 2 here, our little Joule Thief circuit. And then our last journey of the circuit is another BC547 transistor. So our pin 1 goes from our positive rail to pin 1. Pin 3 is another pin 3 to ground. Meanwhile, our pin 2 connects over here to the pin 1 rail and the capacitor of our first transistor. So that is our little Joule Thief. And like I said, this is a transformerless Joule Thief. So off camera, I have built one. And it's your classic hand, basically a wire, our little wireframe Joule Thief. So we have our positive from our voltage source or battery. We have our negative source, and the negative is pretty much a pass-through. Positive is pretty much a pass-through. It's all the little bits in the middle that makes this whole wackiness work. So we'll move our little schematic out of the way. And then we'll come back to our little power source here. And we're going to set this to what my tested voltage was, which was around 1.7 volts. So there's our 1.7 volts tested, loaded circuit. So now we'll just connect our little Joule Thief here. So the bottom of the rail here is our negative. And this is our positive rail. So now we'll connect our some leads here, so we can hook up a LED to see if an LED will light. So there's our negative rail. And our positive rail is up here. So now we have our voltage. So now our goal is to see if we can run a 3-volt LED. So I just happen to have here's a candle. This is a white candle flicker LED. It's a 3-volt LED. So as with any LED, the longer lead is the positive, and our shorter lead is the negative. So we're going to connect our positive here. Get our probe to cooperate. We are lighting a 3-volt LED off of 1.7 volts. So if anybody knows how a Joule Thief works, we know that there's a little bit of black magic in here, because we all know that there's no way in hell that 1.7 volts is going to run a 3-volt LED, and that's just the way it is. So that's that. Now, can it run a RGB? So here's an RGB, because that was one of the wishes that Jay had, was to have an RGB running. So we definitely have an RGB running, but it's not really going through its colors. So I don't know if this RGB is defective. Could be. Because I just happen to have one out here at random. But I would assume that it's going to work. So that's pretty much the theory of this particular video, is that if we have to, we can put a little Joule Thief in line to see, at least we can get a different color LED to run in some of this equipment here. So like Jay said, that he wanted to have a, in this particular one, an RGB running for the caller ID thing here. So that is theoretically possible. And, you know, if the Joule Thief can run it, because sometimes I think what how a Joule Thief really works is that it's pretty much sending out high frequency pulses out. So maybe sometimes that the little controller in there inside the LED may not like the voltage pulses, because sometimes it could reset it. Like if I put it up to a regular battery, it's going through its colors. Stay. So we can try that little experiment again and see if it gets this to flash. So it's pretty much stuck in the blue state, but maybe we can add like a little capacitor or something like that. So let's see if I got a, where's my little capacitor set here? Because sometimes that pulsing can, sometimes it resets that little chip in there. So let's try putting a little capacitor in there, and we'll just pick anything. Let's see, what do we got here anyway? Got all 50 volts. Okay, small ones. Here's 16 volts. There's a 10 volt. Let's try a 10 volt, 220 microfarad. Let's see what that does. That's not going to work. Probably drawing too much current to make the Joule Thief run. So we can try a different one. How about a smaller one? Let's see what that does. Drawing too much. Drawing too much. But at least we can get a different color LED in there. To at least get a brighter LED in there. So this is the kind of experiments that we do here, to see what works and what don't work. So that was the purpose of this video, to see at least we can get a little bit different LED into these devices. So that's it for this video. And of course, stay tuned when I apply all this stuff to these gadgets here. So thanks for watching, and we'll see you on the next video. Bye-bye.